Ika, we're on your stand here at the BIEMH show. Now, we've got a tremendous BIEMH machine here, and everybody knows the capabilities of a machine like this. But what I want to talk to you about is iMachining from SolidCAM. That's what you're using to program this machine, isn't it?
Yep. We have a grid machine, a BIEMH grid machine. Also, we have a grid cam with grid capabilities, such as you have said, iMachining.
Oh, now, what is iMachining? Let's go back to basics in a sense. Okay. Maybe explain what it is and why people should be using it.
Okay, iMachining is a strategic patented by SolidCAM, in which we can get advanced, such as a trochoidal milling operation, in which we get adaptive milling also, to get more or less an average of 35% of reducing time.
So the aim is to be more efficient, is it? To reduce the cycle times, to reduce tool wear. And if you take a part like this, iMachining will essentially create the tool paths, create the program, the algorithm will work out the best way to make this part. Is that really where we're at?
Yeah, that's it. We can give information about the machine, about the material, about the tool, and the algorithm decide the best way to make the tool path to reduce time and increase also lifetime of the spindle, and also, most important, lifetime of the tool path.
So in years gone by, if I was employing or recruiting an engineer, I'd be looking for someone that was clever enough to be able to reduce cycle times by using a control system on a machine. But now you don't need that really. You can basically rely on iMachining or a product like you've got to really create those wins.
Yeah, that's it. It's much more easy to do it with a CAM system that helps you to reduce this time and to help you to program it.
So how does it decide, though, what tool paths to take? I mean, is it taking into account the material, the tools that you're using, the power of the machine? Does it take into account all of these factors?
Yeah, it can do it very simple, because we have tested in several machines with several materials, several tools, so you can be safe when you program with any part with iMachining.
Because I noticed when we were looking at this on your PC a minute ago, that the tool path for machining, almost like the angled flat, was doing it in a different way to how I would have looked at doing it. I mean, did the algorithm decide, or the black box or whatever you call it, that that's the most efficient way to machine it?
Yeah, that's it. If you have a big part, the algorithm decides to cut this big area in several small areas to manage these small areas in a different way to be more efficient.
And what does it apply to things like roughing and finishing and every aspect of machining, or is there certain areas where it's best? Where's the biggest gains? You talk about 35%.
Yeah, the biggest gain is in roughing operations. You can remove a big amount of material in short time. It's not a finishing operation. It's just a roughing operation. If you want to finish the part, you need another operations to do that.
And I look at this machine as being quite an advanced technology, 5-axis, your 5th-axis table here, your rotary table here. Does your software from SolidCAM, the iMachining, apply to more basic machining functions? So, like a small vertical machining sensor, or is it applicable in those areas as well? Yeah. And is there value at that point?
Yeah, it's not just for complex machines. You can use it in 3D-axis machines with low power. You can use also in that kind of machine, or even in biggest one.
What about turning as well, though? Here we're talking about milling and prismatic parts. What does SolidCAM offer in that area? Does iMachining apply?
We have another strategy for milling, for some kind of trochoidal milling for turning operation. In this case, iMachining is more focused on of milling operations.
And you talk about trochoidal milling. This is an interesting area because trochoidal milling is just kind of a set machining path, isn't it? Yeah. When you kind of produce or perform operations like this, you take into account lots of different factors than just trochoidal milling, don't you?
Yeah, yeah. Also, for sure, there is a part or area in which we are going to use trochoidal milling, but it's not a trochoidal milling operation. It's more than that. For example, if you are going to machine a narrow part, for sure is going to make trochoidal milling because it has not more space to reposition the part, the tool. But it's more than a trochoidal milling operation.
How important is it to have CAM software like this when you invest so heavily in a machine tool of this nature? Would it be crazy to try and machine parts without being efficient with CAM, in your opinion?
Yeah. So the complexity of the parts is going to is increasing, so you cannot program a part like that. For example, with a control that it's a good control, they are good control. They have a lot of help that helps to you to program the part. But it's better to do that with a CAM system because you can simulate operations just before came into the machine, and you are going to be more safety when you put.
You don't have to worry about having an accident.
Yeah, for sure. Yeah, it's very important.
You work with, I see up on your banner up here, you work with so many machine tool companies, don't you?
Yeah.
How popular is the software around the world? How big is SolidCAM?
SolidCAM, we have a lot of big customer base and all over the world. We are starting here in Spain, and we are getting a good base of customers, and we are getting more and more with time. But for example, in Germany there are maybe 7,000 customers, so it's a big customer base. And in other countries there is also a big customer base because we are here for more than near 40 years. So.